Like every other year, ASH had a lot new to offer in the MPN field, both in terms of new drugs, which I find most exciting as a clinical trialist, and then also in terms of biology and just some retrospective chart review type of studies. So just to start with, MPNs as a whole, you have to mention the late-breaking abstract that on Tuesday morning that talked about the ontogeny of MPNs and how the driver mutations can be acquired in childhood, even in utero, so even before birth. So the driver mutations have a really long latency in actually causing the clinical phenotype. And there's this very long latency over decades since they are actually acquired. So that was a fascinating work from Jyoti Rangalia and colleagues. There was a similar study from the Mulally lab and Mulally and colleagues in Boston, also kind of tracing the hierarchies of these driver mutations and looking at the clonal dynamics of eventual MPN, clinical MPN evolution. And then, before we get into specific disease entities, our group also showed, Lucia Masarova was the first author of this one, how the survival of myelofibrosis patients has improved over the last decade. And this is important because, we often quote a 2012 study from Cervantes reporting on European data, noting that the survival is improving, or was improving. This is 2012 publication, but that it was primarily restricted to the lower risk patients, not to the higher risk patients. And remember, Ruxolitinib was still fairly young then. That was in 2012, and it had come out in 2011. So now, after a decade of Ruxolitinib, our group was able to show that the survival of myelofibrosis patients is improving over time, and probably in part, at least, due to this drug. So I thought that was important. And then just to close on the MPNs in general, there was some good biology abstracts, and it's really hard to keep all this straight after a deluge of information over the last few days. But something that struck me from Dr. Kilajian's lab, or from his group rather, was the importance of NFE2 mutations. NFE2 is a transcription factor and looks like is implicated in worse survival as well as increased risks of leukemic transformation. Similarly, and I think also from his group, there was work on SF3B1, and that's a gene we consider a good one to have in MDS, in myelodysplastic syndromes in lower risk MDS. But here again, it's one of the splicing factor mutations, and it seemed like it had an adverse outcome. So perhaps two new genes that perhaps could be added to our list of high molecular risk mutations potentially. So that's something I thought I should mention.